5 centimeters. So they have the same size, and let's say it's parallel as well. They're the lines in my book, for example. That's a palm. You see, both equal because they're both 5 centimeters, both parallel. So all I do is close it up here. You see, it's definitely a palm. It'll be parallel both sides. Okay, is that one good? So therefore, ABCD is a palm, one pair of opposite sides, both equal and parallel. Alright guys, I'm not too sure if you've written all that down already. The next one, while I'm waiting for you to write, will be exercise 4. As I say, if you didn't get all the writing, don't worry. I'm going to scan all of this with my computer now when we're done, and I'm going to upload it to you. Okay, I'm going to send it up. Right, so here we have the next one. I'm just trying to think. Lessons 7 and 8. The next one will be exercise 4, page 202. So exercise 4, page 202, number 2 will be next. This one was number 1. This one was number 1. Next one will be number 2, right? Right, this is actually the 9th example. Okay, so we're almost there. Right, so I'll tell you what, with all the knowledge you have now, see if you can tackle that one quickly on your own. And I'll be with you in like 1 minute. Just see if you can, like, look at it quickly and have some thoughts on it. And then we'll see from there. Okay, so looking at this one, ABCD is a palm. ABCD is a palm with AE equal to FC. So AE is equal to FC. Prove that BEDF. So prove that BEDF is a palm. So class, just by looking at it, you can see they're placing a palm which they want us to prove. So they're placing this palm which they want us to prove into another palm. Surely by common sense, that's a palm. Okay, so notice how they told us that one side, this piece is actually equal to this piece, right? So that means if the whole outside shape is a palm and AD is equal to BF, then that means this remaining piece from there to there must be equal to that remaining piece from there to there. If the whole shape on the outside is a palm, this is definitely a straight line. That is a straight line. And if the whole outside shape is a palm, which it is, that means this whole line AD must be parallel to this line BC. So that means that this piece and this piece is also parallel. So there you have it, one pair of opposite sides, both equal and parallel. This stuff is not too difficult. You just have to have like common sense. So notice how we have to apply most times that the opposite sides of a palm are equal, and we have to apply that the opposite sides of a palm are parallel. Or we have to apply that the diagonals of a palm bisect. And if we use those properties, so if you see lines crossing here, surely the diagonals are going to kick into that example. How do you know what to use? Very simple, class. All you have to do is say, listen, they want me to prove this is a palm. This is a palm within a palm. So what's the properties of the outside palm? The opposite sides are parallel, the opposite sides are equal. So you use those things to prove the other one. That's how you do it, okay? Now let's look at the first statement. They tell us that AE is equal to FC, so that's already given. They said prove that BEDF is a palm. Now they tell us that ABCD is a palm, so we can say clearly that this is parallel to this, right? Why we can mark this parallel? Because the outside shape is a palm. We also know that this is parallel, right? Which I don't think we're going to need. We're not going to need this part, that this is parallel to that, because there's your straight line there. So if you can prove one pair of opposite sides equal and parallel, then it's a palm. Right, so first statement, AD is parallel to BC. AD is parallel to BC, so AD is parallel to BC. Opposite sides of a palm are parallel. Opposite sides of a palm are parallel. Therefore, ED, so you see, therefore, because this is parallel to that, therefore this is parallel to that. So therefore, ED is parallel to BF. AD is equal to BC. So AD is equal to BC, and AE is equal to FC. So AD is equal to BC, AD is equal to BC, opposite sides of a palm. AE is equal to FC given. So that means the piece has to be equal to the piece. The piece has to be equal to the piece. Therefore, ED is equal to BF. Therefore, ED is equal to BF, the piece being equal to the piece. Therefore, BEDF is a palm, one pair of opposite sides, both equal and parallel. One pair of opposite sides, both equal and parallel. Right, class, is there any other example from the textbook? Or, yeah, I think from the textbook, if you can just give me the page number, and we'll call this the last example after this. Just give me a page number. I'll go and get the textbook quickly. Page number, exercise, whatever, what number. Just check through your textbook and tell me which one. And then I'll draw the diagram, because I don't see this. I printed it earlier because I knew which ones I was going to teach you. So just tell me which one. I'll draw it quickly and then we'll look at it. But from the textbook, right? Because if it's a question paper, okay, if it's a question paper, if you have one and it's one example that's giving you some help, what you can do, you can take a photo and you can send it on the group. I'll just try and get my phone quickly. Or what you can do, if it's in the textbook, just take a photo of it. But take a clear picture and just send it on the group. Yep.
I'm gonna turn my camera on. I just wanna see if are they gonna make us like prove a kite or something like that, or is it only gonna be parallelograms?
Yeah, sometimes they can ask you to prove a kite. To prove a kite, all we have to do is prove that the adjacent sides are equal. So normally, they'll tell you this is 90, that one's 90, this side equals to that side, and you prove those two top triangles in your kite congruent. Then you prove the next two, the two longer triangles, also congruent. And then you say it's a kite. But if you got it, I can do it. You
So
can
it's on page 207 and number 13. I'll put my camera on.
Okay, 207.13. My textbook's not far, so I can get it. 207.13.
So there's it, it's this one.
Okay, you're going to hold it there.
Yeah, so.
Okay, just come a little down with your book. Okay, keep it steady there, right? I'll try and show that quickly. Let's try and show it. Okay, so A, B, C, D. We got 1, 2, 3, 1, 2, 1, 2, 1, 2. Right. If you can just come a little down with the books, I can get the top stuff. Thanks. A, B, C, D is a kite. A, B, C, D is a kite. Oh, so here they mostly want you to work out the angles then. A, B, C is a kite. The diagonals intersect at E. Okay, we can leave that statement. You can see it on the diagram. BD equals 30. BD equals 30. And AD equals 17. And DC equals 25. Determine. So they want us to find AE. Wants us to find AC. They want us to find B1. B1 if A1. If A1 equals 20. Okay,
Sir.
I have it. Perfect, thanks.
Okay, sir.
So, close. I don't know if you can see this. It's in pencil. Is it clear enough? The kites over
Yes,
there?
it is.
It is good. Okay, my camera is quite good, you know. Right. Let me get a pen. You know how to write with a pen, then you can see clearly. Right. Let me just get make statement reason here. See, it's good to draw this line even in your when you do the geometry in exam, so that you remember statement reason. Otherwise, you could forget and not write any statements. That's what happens with some children. Right. So they tell us that ABCD is a kite. So A, B, C, D. So this whole shape's a kite. They tell us BD is equal to 30. So what they're trying to say is from here to here. They're saying from here to here is 30. So all your properties of a kite, you must know them. Right, AD is 17. So AD, that's from there to there, is 17. And CD is 25. So for CD is 25. Right, so it's best to always take the information from here, stick it on the diagram, makes sense. Class is a very easy question, right? I'll tell you why. You must remember that kites bisect at 90. There's only 3 shapes, okay, in geometry that bisect at 90. I'll give you them. It's a rhombus, bisects at 90. Good is to write this in your book on the side here, okay? Next to this question. A rhombus, a kite, and what's the other one? Rhombus, kite, I forgot now. Rhombus, kites, and they bisect at 90. Rhombus, kite is another one. Let me think of all the shapes now. Okay, not a rectangle, right? A rhombus, kite, and a square. Bisect at 90. Right. So you'll find where they meet up here in the middle, it'll always be 90 degrees. Okay. They'll always be 90 degrees. So class, remember that a rectangle, I don't know if you can see here in the bottom. I'm not too sure. Okay, can you see what I wrote here? Rhombus kites thing. I don't know if it's in the camera. Okay, I think somewhere here it should
So
be.
it's there.
It's there now, right? Because I was just looking at my lines on the tablecloth there, so I realized that it could have been a bit out. Right, so now let's look at a rectangle. Many children think that a rectangle will be 90. Not possible. You can see that's an obtuse angle, right? Not possible. Let's look at a square. See, definitely 90 on a square. You see that? A rhombus as well. Definitely 90 on a rhombus. And obviously our kite is 90. Right. So those are the only 3 shapes where they bisect at 90. Please note, not a rectangle, okay? Rectangle, no. Right. So let's look at it. So notice they gave us BD as 30. You have to ask yourself, why did they give us that? Because you see the diagonals on a rhombus also, diagonals on a kite also cut in half. Okay, but only this diagonal cuts the values of this side and this side in half. You agree? Not this one. This one, from there to there and from there to there, is not equal. Only if the kite is a rhombus. Okay, so sometimes a rhombus can also be labeled as a kite. So notice the shape now will be like this. You see, it's just a rhombus standing up. So now all sides will be the same. You see that? So therefore, this piece and that piece will be the same. That piece and that piece will be the same. Okay, so if the kite is a rhombus, then yes, this piece will be equal to that piece. But if it's a normal kite, it won't be. This piece will be short, this piece will be longer, but this piece and this piece will always be equal. The easy way to understand, look at it like a cross, okay? So you see this, the diagonals are actually like a cross standing up, right? So let's look at it. So how much will be, what letters is this here? Oh, it's E. It's E. I didn't see the E here. BE. So BE is equal to GE. So 30 divided by 2 is equal to 15. Okay, so BE is equal to DE is equal to 15. Right, so notice we already have this piece here as being 15. That piece is 15. So guess what? If they wanted you to find AE, can you calculate it? Can you? What you think?
Yes, sir.
Using what?
Isn't Pythagoras?
Pythagoras, perfect. So AE is equal to, so when I do Pythagoras, I don't write A squared. I go straight to the square root sign, okay? And then this is the hypotenuse, right? You know how to establish the hypotenuse? The hypotenuse is my red pen. The hypotenuse is always opposite the 90. Okay, so opposite the 90-degree angle will be your hypotenuse. So then we're going to say 17 squared subtract, what is our value again here? 15. 15 squared, 17 squared, I can't remember, but I know this is 225. I think it's 284 if I'm not mistaken. Just punch into your calculator 17 squared. I don't have a calculator here. 17 squared, what do you get? Anyone with a calculator there? Let me just check on my phone for calculator. Calculator. 17 squared. 289. I said 284. Stupid me. I knew these numbers off by heart at one stage. So 289 minus 225. 64. Square root of 64 is 8. Now, class, if you do it like this, 8 centimeters. If you do it like this, you will find you will never make a mistake of doing the Pythagoras. Now, if you do it this other way, which we learned in primary school, we said AE squared is equal to whatever squared plus whatever squared, right? So the person ends up with an answer here, but he forgot to square root that answer. You see, so what he actually calculated was AE squared and not the square root of that answer. So he didn't calculate AE, but AE squared. So class, this is the reason why I moved the square root sign immediately over. First step. Okay, so you'll always get the correct answer. Right, so that will give us 8. So AE, that's this distance here now. AE is equal to 8. Okay, so now we need to find AC. AC is which one? Okay, AC is the full length. From there all the way to there. All the way. So once you got that piece, that means all you have to do is calculate this piece, add that piece to that piece. Can we calculate this piece here? CE. Can we calculate CE? I forgot the reason here, guys. Pythagoras, and here is diagonals of kite. Forgot the reasons. Right. So how will we calculate EC? Very simple. Pythagoras also, because we have that piece there. We said it was 15. That piece is 15. This piece is 25. So we are going to say, I think I need to push this up a bit so you can see. I think somewhere there should be okay. So 25 EC. EC is equal to the square root. And we're going to have 25 squared minus 15 squared. So 25 squared minus 15 squared. 25, if I'm not mistaken, is 625 minus 225. So 625 minus 225 will give me 400. Square root of 400 will give me 20. EC is 20 centimeters. Right. So now that we have EC being 20, what is the distance of AC? So they want us to find AC. AC is equal to, I think I should push this up. AC is equal to 8 centimeters. The 8 we worked out. So it's the 8 plus the 20. That's going to give me 28 centimeters. They say calculate, don't forget the reason here, Pythagoras. If you don't write the reason, you lose a mark. Pythagoras. Calculate angle B1. So this is angle B1. If A1 is 20. So A1 is 20. So A1 is 20. Who knows what's this angle here? It's 90, right? So then we're going to say angle B1 is equal to 180 degrees. Subtract the 90, subtract the 20. I don't know if you can see the diagram anymore. Subtract the 90, subtract the 20. And so we're going to say 180, subtract 90, subtract 20. That will give us the B1. Let me just push the paper up. I think somewhere you should. I think somewhere you should see. I can see my pen a little bit in the screen there. So it's 180 minus 90 minus 20. So that will give us 90 minus 20 will give me 70. Don't forget sum of interior angles of triangle. Okay, so sum of interior angles of triangle. And B1 is now 70. Right, class, I hope that was good. Right, we'll leave it there. I'll put the whole memo of what we just taught now on the group in case you didn't get some of the answers in between. Okay, obviously I won't have the answer for this. Okay, so before we disconnect, I'm just going to leave this out here. I hope you can see all that calculation in the camera there. I can raise my camera up a bit. I don't know if you can still see. Right, so maybe just copy that down and then you can disconnect. I'll send it on the group. Okay, so I'll leave my camera on for the next few minutes. Right, class, I hope that was informative and it made some sort of help in your life. I hope this video is on the Teams, and maybe there's a way I can copy it, so I'll explore that, and hopefully I can send it to all the others. There was only about 7 of us connected or so, compared to the whole class. Okay, class, thanks.
Bye, sir.
Okay, bye, guys. Okay, Tando, you can still write. I'll leave the camera connected for the next few minutes.